Hi everyone, this video is the first for the unit on linear equations. So in this video we will go through section 6.1 in your textbook and talk about just some of the fundamental concepts from algebra that you need to know or possibly review so that we can use the right vocabulary and just all be on the same page with what exactly we're talking about when we get to solving equations. So let's talk about algebraic expressions, variables, simplifying, things like that. Okay, so some basic definitions. Algebra is a branch of mathematics that generalizes the concepts of arithmetic by applying them to quantities that are allowed to vary. Right, so we're introducing these variables, which are represented by letters, and they're quantities that can change, right, from problem to problem, and they represent unknown values. All right, so for example, in the equation 3x equals 6, here the letter x represents the number that makes this a true statement. X represents the number 2, since 3 times 2 is 6. All right, but in the statement 3x equals 12, now x represents something else. Here x is a 4, since 3 times 4 is 12. All right, so it depends on the problem, and you may have seen these before. Okay, so variables change, they vary in value, and the only exception to that would be within a single problem. So if you had the equation 3x equals 6x plus 8, okay, so now we're in the same context. So now these x's both represent the same value. An algebraic expression is a combination of variables, numbers, operation symbols, and grouping symbols. And grouping symbols are things like parentheses and brackets. And if we needed them, we could even throw some braces in there, just another shape of parentheses in this context. All right, so here's some examples. 3x plus 2. This has a couple numbers. It has the plus symbol, that's an operation symbol. It has a variable x. 8x squared. Okay, so we're using an exponent here, and that wasn't in our list of things here. You can think of it kind of as an operation, or you can think of it as just a shorthand way of writing x times x. And then in that case, we just have numbers and variables in this expression. 111. Okay, something doesn't have to have all of these things. Okay, it could just be a single number, and that counts as a very simple type of expression. 9/5 c plus 32. And then 7 times the quantity 2y squared minus 5. Okay, now an important note here. This is in your textbook. An algebraic expression does not have an equal sign in it. D equals RT is an equation, not an expression. Okay, so none of these things are equations. Algebraic expressions are made up of one or more terms. Terms are the pieces in an expression that are separated by addition or subtraction signs. Okay, so for example, 3x plus 5, that has two terms. It has the term 3x and the term 5 separated by a plus sign. Okay, if we had 5x minus 7, you can think of this in two ways. You could think of this as 5x and 7 separated by a negative sign or a minus sign. It's also a little bit more common to think of this as, every time you see a minus sign, think of this as plus a negative number. And then your terms would be 5x and negative 7 separated by a plus sign. All right, every term has a numerical coefficient, or we mostly just call this a coefficient. All right, so in the term, the second one, 5x minus 7, the coefficient of 5x is the number that comes at the beginning of the term. Okay, so the coefficient in this case is 5. Okay, now here you may see why we prefer to think of this as a plus negative 7. If you're asked what the coefficient of that term is, the answer is negative 7, not positive 7. All right. Let's try one more. How about negative 15y squared minus y? Okay, well, the coefficient of this first term is negative 15, and the coefficient of the second term, right, it is negative because of that negative sign. And if you don't see a number in front of the y, there's a 1 there that we don't write. It's implied as a placeholder. All right, how about this one? Identify the terms of the algebraic expression and the coefficient for each term. Okay, again, another math note from your book. The negative sign is considered to be part of the term. All right, so first of all, how many terms are there? Okay, we have 4 terms. And I know this just by looking for the plus or minus signs in the middle. Okay, so I see 3 little dividers there, so there are 4 terms. Okay, so the terms are negative 8y, 5 halves x cubed, xy, and negative 3. Okay, and then what are the coefficients? Those would be negative 8, 5 halves. If you don't see a number, it's a 1, and negative 3. Okay. Do you remember the special name for a term which is just a number? Okay, so we have some terms like this, negative 8y, that's called a variable term, since it has a variable in it. Okay, what's the name of a term that has no variable, like negative 3? That is a constant term. Okay, it doesn't change its value based on what x or y is. It's always just the same number, negative 3. All right, another thing you need to know is using the distributive property. All right, so sometimes you'll just be asked to simplify. Other times it will say multiply or use the distributive property. All right, so anytime you see this parentheses with a number in front just kind of squished up against it, that means multiply. Okay, and the distributive property says multiply or distribute that to every term inside the parentheses. Okay, so this would equal 5 times 3x, and remember you multiply the numbers 5 times 3, that becomes your new coefficient, and then you leave the variable with it. Okay, and then the next one, 5 times 7 is 35. Okay. Now, there's one other property. This is interesting, I think. There's one property that we kind of glossed over here that we actually used. And here's what this would look like if we wrote out all of the steps. We don't usually do this, but we would usually write this as 5 times 3x. Okay, 5 times 7. All right, so this is what it would look like with all the steps here. Then we would regroup here and say, okay, well that's 5 times 3 times x. Okay, plus 35, you can multiply that. And then finally 15 is 5 times 3. All right, so what's that extra property? It's actually right here. Okay, and maybe it would help if we added in a parentheses around the 3x. So basically we switched it from saying that this is 5 times 3x to 5 times 3 times x. So we changed the grouping, we added in the parentheses in a different place. Okay, do you remember what property that is? That is the associative property. Okay, so a lot of those properties that you learned in section 5.5 are applied in algebra. They're just kind of hiding behind the scenes, making things work. Okay, let's try the next one. This is the distributive property with 3 terms, so it's kind of an extension of the distributive property you learned that was like a times b plus c. Now it's like we have a times b plus c plus d times 3 things. All right, so same idea. We're distributing the negative 3. Okay, so we have negative 3 times 6a. is negative 18a. All right, and I've skipped over and haven't written it out, but we did use the associative property again to group the negative 3 and the 6 together before adding in that a. All right, negative 3 times 7b is negative 21b. Okay, and instead of plus a negative, we usually just write minus. And then negative 3 times 10 is negative 30. Okay, so there you go. Simplifying. What exactly does that mean when you see these directions? All right, well, sometimes it means combine like terms. So when two terms have the same variables with the same exponents, we will call them like terms. So see if you can think of some examples. Okay, here's one. 3x and 5x are like terms. They have the same variables, x and the same exponents. Now it's not written, but it's implied these are both ones. Okay, another example of like terms would be 5y squared and negative square root 3y squared. Okay, so same variables, the y's, same exponents, the 2's, okay, and then just different coefficients. What about 3xy and 3yx? Okay, these are like terms. They have the same variables, x and y, and the same exponents, ones on each of them. Okay, now it's important that the exponents on the x's match and the y's match. It's not important that x matches y. So these still would have been like terms if we had like x squared y and yx squared. That's okay too. All right. Now if we wanted to combine these, combine like terms, like let's say we were adding these. All right, well, how do you write that? Well, we definitely add the coefficients. Okay. And then you have an option, your choice. You can write x, y, or yx. Usually we'll just write this in alphabetical order. That's kind of like standard form. Okay, so combine like terms using the distributive property. So here's how this works. 9x minus 20x. I'll write this out the long way. Once or twice you can see what this looks like, but usually we'll just skip the middle step and jump right to the answer. All right, so notice that both terms have an x, so the distributive property, using it kind of backwards, you can take out that x and say that this is 9 minus 20 and leave the x undistributed. Okay, or in algebra we would say factored out. Then you combine the coefficients, so that's negative 11, and still multiplied by x. All right, but in practice we'll usually just jump right from here to negative 11x. The next one, these terms all have x squareds in them, so this is 3 plus 8 minus 2, all in parentheses, with an x squared. And then combining all of those coefficients, we have 9x squared. Okay, and then this last one, these are not like terms. We have an x and an x squared, so these cannot be combined. All right, so we said if possible, so you would just leave your answer like that. All right, simplify each expression. So now the instructions are a little bit more vague. Basically, we want to combine all the like terms, do any distributing that's necessary, and we usually write things in standard form. So we start with variable terms, and then we write the constants towards the end. Okay, so what properties do we need to use to do this? Well, first of all, if I wanted to combine like terms, like with these x's, notice everything that's in the middle there. So I need the commutative property to move stuff around. Okay, so I could do 9x, I could move the 10x next to it. Okay, negative 7y. I could use the commutative property to put the 6y next to that. All right, I need the distributive property to factor out the x's and y's. Okay, so I'd have like 9 minus 10 times x. Okay, and then here you would have put a plus sign here for right now. Negative 7 plus 6 with a y, and then 18 minus 27. And then I would combine the coefficients, so we would have negative 1x, or just negative x. And then negative 7 plus 6 is negative 1, so negative y. And then 18 minus 27 is negative 9. All right. Second one, same idea. We need the commutative property to move stuff around and the distributive property to combine like terms. So I will skip over some of those middle steps and we'll just jump right to the answer. So I would look through and find the highest exponent first. And that's this 4x cubed and this 3x cubed. Okay, and let's combine those. So that would be 7x cubed. Okay, then the x squareds. We've got a 4x squared, a negative 7x squared. So that's negative 3x squared. Okay, then the x's. We have negative 6x and 2x. Negative 4x. And then finally the constant terms, 10 and negative 6 is positive 4. Okay, and that's fully simplified. We've combined all like terms. And I've written this in the kind of the preferred standard notation with the highest exponents first. All right, try this one. Notice the parentheses. So one thing we need to do before we can combine like terms is use the distributive property. Okay, so multiply 8 times each of these terms, 3 times each of these terms. And this is actually also the distributive property. Here I'm distributing a negative 1. Okay, so there's no number written, but distributing a negative sign or a negative 1. Okay, so that's going to look like 24x squared plus 40 plus 6 minus 3x, then minus 5x squared minus x. Okay, and then I can combine the x squared terms. Those are like terms. And that's 19x squared. Okay, and then the x terms, negative 3x and negative x. That's like negative 1x. All right, so that's minus 4x. And then finally 40 and 6 is plus 46. All right, evaluating expressions. Evaluate 9x minus 3 when x equals 5. All right, so evaluate has the word value in it, so we are trying to find the value, the numerical value of the expression. And we want to substitute this 5 in place of the x, since they are the same thing in this context. All right, so I will replace the x with a 5, and since it's a number, I can't just write 9, 5, so we put that in parentheses to show multiplication. Okay, and then we work that out using order of operations. So 9 times 5 is 45, minus 3 equals 42. Okay, and then finally this one. Now here it's especially important to put in parentheses. And remember that the value of something squared does change whether or not the negative is inside parentheses or outside like this. Okay, so we'll either get 9 or negative 9. All right, so basically whenever you're evaluating with variables, it's a good idea to put those parentheses in all the time. Okay, so then 7 minus 7y, y is 6, plus 2. And then order of operations, we should do exponents first. So negative 3, that quantity squared is positive 9. Okay, negative 7 times 6 is negative 42 plus 2. Okay, I guess I skipped ahead with order of operations there. Doesn't make a difference since I won't do this subtraction till after I've done both multiplications anyway. Okay, so I should have done 45 first, then made that 42. Okay, so 45 minus 42 is 3, plus 2 equals 5. Alright, that's it for this video. Just some basics to get you started. Review some of the fundamental concepts from algebra that you need to know. and we will move into section 6.2 and start talking about solving linear equations. All right, thanks for watching.